All right, let's talk about something that so many of us run into with modern apps. How do we handle really complex connected data? What happens when the relationships between your data points are actually way more important than the data points themselves? This is a huge challenge, so let's dive in.
So, why is it that these modern applications just seem to break the good old databases we've relied on for decades? Well, it's a fantastic question, and the answer might surprise you. It's not that the data itself is all that different. It's the absolute explosion of connections between all that data.
See, on one side, you've got your traditional relational databases. Now, they are fantastic for nicely structured records. But the moment you ask them to trace a complex path through a ton of relationships, what we call deep traversals or recursive joins, they just slow to a crawl. But then you have graph databases, and they are built for this stuff. They absolutely excel at these multi-hop queries, finding those hidden connections in pretty much real time.
And look, this isn't just some academic theory. These are the challenges that developers are facing every single day. I mean, how do you build a recommendation engine that actually knows what your friends bought? How do you spot a sophisticated fraud ring that's using a tangled web of accounts and devices? Or map out a complex IoT network? When you get right down to it, every single one of these is a relationship problem.
So it makes sense, right? If the problem is all about relationships, the solution has to be a model that thinks in relationships too. And this is where our hero, the graph data model, finally enters the story. It's a totally different way of thinking. You're shifting your focus from individual records to the connections between them.
Now, a graph really only has two basic building blocks. The first one is called a vertex. And you could just think of it as a node or a thing. It's a person, a place, an object. It could be a user in your system, a product you're selling, or even a single transaction. It's basically the noun in your data story.
And if vertices are the nouns, well, edges are the verbs. And this right here is where the magic happens. An edge is the line that connects two of those vertices, and it defines their relationship. A user purchased a product. A device is connected to a sensor. This is where all the context lives, and it's the source of the graph model's real power.
Okay, so we've got the graph model as our big idea, but what's the tool that makes it real? Well, for our story, this is where Azure Cosmos DB comes in, and specifically its Gremlin API, which takes this powerful graph concept and turns it into a fully managed service that you can scale across the entire globe.
Now, not all graph databases are created equal. Far from it. So let's talk about the specific superpowers that make Cosmos DB a really unique choice for these kinds of relationship-heavy applications.
We're going to zero in on 4 key superpowers. It's true global distribution, elastic scaling that just works on demand, the ability to write your data anywhere in the world at the same time, and this one is a game changer, automatic indexing that saves you a massive amount of operational headaches.
First up is global distribution. And honestly, this is huge. We are not just talking about having a few read replicas. We're talking about the ability to replicate your entire graph, the whole thing, to any Azure region you want with literally a single click. This is the kind of thing that takes teams months to build themselves. It means your users in Tokyo get millisecond read and write speeds from a database that's right there in Japan.
And that global reach, it powers some incredible reliability. When you turn on multi-region writes, Cosmos DB gives you an industry-leading 5 nines availability SLA. That's 99.999% uptime, a promise that's just ridiculously hard and expensive to try and build on your own.
So, how do you handle scaling? This is where this cool concept called request units, or RUs, comes in. Just think of it like a universal currency for your database performance. Instead of trying to juggle separate costs and limits for CPU, memory, and I/O, you just provision the amount of this performance currency you need. It makes capacity planning so much simpler.
Now this is a massive win for developers. In most databases, you're in a constant battle, manually creating and tuning indexes just to keep your queries fast. Cosmos DB just flips that whole script. It automatically indexes everything, all your vertices, all your edges, all their properties, by default. So your queries are just fast right out of the box. No indexing expert required.
Okay, so we've covered the what and the how. But now, let's get to the fun part, the why. Where does a globally distributed, fully managed graph database actually make a real difference? Let's look at where this technology really shines.
The applications here are just incredibly diverse, from fraud detection all the way to social networks. But they all share that same common thread we've been talking about. They are built on complex relationships. And we're seeing huge growth in areas like IoT and supply chain, where understanding those connections is absolutely mission critical.
Let's make this real. Imagine a fraud scenario. You start with just one suspicious transaction. In a graph, you can instantly jump from that transaction to the device that made it. Then, from that one device, you can fan out and find every other account that has ever used it. In just a few hops, which takes milliseconds, you've potentially uncovered an entire fraud ring, something that would be nearly impossible to find with traditional database joins.
And hey, think about IoT for a second. You've got sensors, gateways, and devices literally scattered all over the globe. A graph is the perfect way to model all those physical and logical connections. And when you combine that perfect model with Cosmos DB's global distribution superpower, you get a system that can ingest and query that data with super low latency, no matter where in the world it's coming from.
So we've seen the superpowers, we've seen the use cases, but let's be honest, no single tool is perfect for every single job. So let's get really practical and talk about where Cosmos DB absolutely shines, and maybe where you might want to consider some other options.
This is probably the single most important distinction to understand. Cosmos DB is what we call an OLTP, or operational database. Think of it as being built for speed. It's designed to handle thousands of small, real-time queries every second. It is not an OLAP, or analytical database, which is designed for those huge, long-running queries like running a massive PageRank algorithm across your entire graph.
And you can really see the trade-offs right here. For an operational app that needs to be globally distributed, fully managed, and have multi-region rights, Cosmos DB is pretty much in a class of its own. But if your main goal is to run super deep analytics on a single, massive graph, then a specialized tool like Neo4j or TigerGraph might be a better fit. It's always about picking the right tool for the job. So let's just boil it down. You're going to want to choose Cosmos DB for your global scale operational apps, things like real-time recommendation engines or that fraud detection system. But you should probably consider alternatives if your main job is heavy-duty analytics, or maybe if you need a very specific community algorithm library that isn't supported out of the box.
So what's the big takeaway here? At the end of the day, Cosmos DB gives you a globally distributed graph database that's fully managed so you can just focus on your code. It speaks the standard Gremlin language, which means your skills are portable. And it's purpose-built for those fast, real-time queries at scale, making it a top contender for any cloud-native app where the relationships in your data are the real story.
And that really just leaves us with one final thing to think about. Now that you know what's possible with a database that's actually built for connections, what are the complex relationships hiding in your data that could power your next big idea?